Perfect timing. Okay, so I went nuts on that first one. Okay, what am I going to plug in? What do you think I'm going to ask f of? F of what number? What do you think I'm going to plug in for x? 3, 2, 1, go. 2. Now, this is probably going to disappear again because we just went through a thing here with this. So f of 2. Well, you plug it in. What's 2 minus 2? 0. What's 2 to the 0? 1. Negative. Negative 1, because the negative's on the outside. Negative 1 plus 4. 3. But what I'm saying is that's the most important point. 1, 2, comma 1, 2, 3. Been doing weird things. By the way, where's the asymptote? Y equals, we should do that right now for a exponential. Y equals what? 3, 2, 1, go. 4 is correct. We had a lack of confidence on that, by the way. All right, it goes 4 up. 1, 2, 3. Oh, so when I input that 1 point, oh, this got flipped over the x-axis. That's why it's below. Okay, so that's what makes sense out of that. And then I kind of demand a couple more points. Like, what would be a good one? 1 would be pretty easy. If I plugged in 1, comma, what's 2 minus 1? What's 2 to the first? 2, but negative. You do the negative, so it's negative 2 plus 4, which is what? 2. So just from these 2 points, you should get what's going on. 1, comma 2, I got it. This graph is going to behave like this and then go to the asymptote. Okay, so 1, comma 2 does it for me, and that's an easy one to plug in. 3 gives me that fraction, so I will do that one just for giggles. 2 minus 3 is negative 1. 2 to the negative 1 is 1/2. Negative. Negative 1/2 plus 4 is 3.5. There's the proof. I'm going to call it proof, but we know enough that we know that's where that asymptotic behavior of getting close is. Be nice to plug in 0 for x and get the y-intercept, and that would have been doable. All right? Definitely would have been doable. Right? Let's see if I can hit that. 0. 2 minus 0 is 0. 2, sorry, never was good at math. 2 squared is 4. Oh, yeah, negative 4 plus 4 is 0. Well, thanks for coming. All right, so that would actually be a point right there. All right, is that legal? What is that, a receipt from the coffee shop or something? Let me see it. I don't trust anyone, especially my family. All right, what did I say that online? It's good. It's good. It's good, everybody. It's good. Okay. All right. Whew. Oh, just math. All right. And then the domain is all real numbers. And then the range is negative infinity to 4. So we had a flipperoo over the x-axis. We had a flipperoo over the y-axis, believe it or not, with that 2 minus x. But input-output takes care of what the shape should look like, and you'd be good. Okay, and then I guess so, but I could make this. I guess I didn't, so we'll just leave it. What do you think I'm going to ask f of on this one? Don't say 2. It'd actually be 3. Because what's 3 minus 2? You're right about the f of 2, by the way. We'll get to that. 3, sorry, he's like, oh, all right. What's 3 minus 2? 1. What's log base 2 of 1 this class? 3, 2, 1, go. 0. 2 to what power equals 1? 0. What's 0 plus 4? 4. So I shouldn't complain. Again, I think there was a lot of good, but there are some people that are just absolutely clueless on input output. Okay, and then why should I say plugging in 2 was fine? Vertical asymptote. So f of 2 is undefined, and that's because you have a vertical asymptote there. Oh, okay, I know what side I'm on. But then I did log base 2 because you actually can input some more. I know I keep going back and forth, but I plugged in 3. I can plug in 4 and get an output. What's 4 minus 2? 3, 2, 1, go. 2. So I plugged in 4. What's log base 2 of 2? 1. 2 to the first equals 2. So 1. What's 1 plus 4? 5. So even verbalizing this, everyone should be good. Unfortunately, hope how did you hear that? What did I text someone earlier? Oh, my mom lives in Florida. Second hurricane coming through. Man. First one, she got some damage, was okay. Second one came in from the other side, but it got real big. Almost Florida's covered right now with the hurricane. So I just gave her a text real quick. Is she all right? She seems okay. Getting soaked though, more rain. All right. So domain is 2 to infinity. Oh, vertical asymptote. That's exact. I mean, I should do those at the same time. And I was just yelling at my, you yell at students, Mr. Samuels. I was yelling at my IM tours. How are we screwing up if this is actually, what axis does this cross, by the way? What axis does this vertical line cross? The x axis at what number? 2. X equals 2. Look at our previous one. What axis does this line cross? The which axis? Y. Where? 4. Y equals 4. How are we flip-flopping those? Blah, 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 blah. Okay? Don't be sorry. Just don't do it again. All right. And then negative infinity to infinity. All right? For the range. Okay, let's move on and actually do what we're doing. Okay, dang, I want to freeze this so you don't see anything. Ruh-roh. Someone's getting taken down here. All right, I'm just kidding. All right, Jeremy. Immediately. All right, go ahead. I need to get this. I don't know. Yeah, I wouldn't. Okay. Oh, did I hit freeze? Good. So you don't see anything? All right. So here's the next thing. I want you to solve this equation when this appears, all right? You ready? I want you to solve this equation. 3, 2, 1. What does x equal? Go. There you go. You got it. Who said it first? Okay, so x equals skunk. What is this equation? What is going on? But isn't that what it has to be? Just by matching, just by being a human, and that's an equal sign. So if I replace this with what? Skunk, then these would be equal, correct? All right? Because honestly, this is there you go. Give yourself a hand if you got that. This is this is this is how you solve exponentials when you get equal bases, right? You just kind of do a matching. If b to the x equals b to the y, then what does x have to equal? Y. If log of x equals log of y, what does x have to equal? I don't even have to know what x, or I don't even have to know what LO6 is. What? Okay. So again, this is going to be part of how you're going to solve today. And that's why I like this. By the way, you're so confused. All right. Remember those common errors. We got that. So here's what we're going to do today. In some cases, that skunk equals x equation is going to come into play. All right, when you're solving exponentials or logs. All right, I'm being honest. We actually already done that. How come I can't move myself? There we go. Get you up in a corner, Mr. S. Nobody puts baby in a corner. Anyone know the other one? This is 2 movie references. Which one is it? Dirty Dancing. All right. Okay, that's kind of inappropriate. There we go. Like, cancel Mr. Samuelis. Go for it. You know what? People have tried to cancel me for a long time, and guess what? I'm still here. Okay. so so go for it. All right. So anyway, so number so so the first one is this could happen. Okay, you could get equal bases if you have an exponent. And then this is going to happen a lot for logarithm equations. As a matter of fact, at the end of our notes, I think our last example, this happens. All right, but then most of the times it doesn't. So here it is. This is the key today. If you're in log form and you can't do that log equals log thing, then just change it to an exponent and then proceed on. And guess what? If you're in exponential form and you can't get equal bases, change it to a logarithm. That's it. One other thing you're going to have to do, this was the key to yesterday. If you have more than one log on a side with operations, you got to condense. That's all that says. And then it could be any of these cases up here. It could be the second or the first case, is what I should say. So if you have several logs in a logarithmic equation, you got to use a rule, and then it could be either one or two occurs. Change it to an exponent, or you have log equals log. And that's really the day today. All right. That's and I think I have too many examples. I might go to each section and hit one and get to the hard one at the end, and then continue the video and just do some extras for anyone else. And then you can do whatever you want, but not talk and interrupt the movie. All right. Because actually, I had somebody, we won't say who, come into Compass today for something else, and we weren't doing anything. I go, hey, you want to see today's lesson? That person got almost all the homework done during Compass because it's actually not that hard. We won't say who they are. Are they in this classroom? I don't know. Okay. Who is it? He didn't come today. We didn't know what to do with ourselves. All right. So here's a problem, though. This was mean. That number is awfully large. But do you know what? I got irritated. I get irritated a lot. I'm sorry, but I got irritated with people trying to break down 81 last during tutoring. What's 81? What times what? 9 times 9, and what's 9? What's 9? What times what? How many threes do you count? 4. So 3 to the 4th equals 81. It's like rocket science. Blew their mind. Okay. Hey, and then guess what 3 times 81 is? So 243 is 3 to the what power? 5th. It's one extra. Did someone get it wrong? Somebody still got it wrong. It's just one more 3 multiply, which means 3 to the 5th. Still got it wrong. Okay, so this was number 1 of those sentences. Did I give you enough time to write those sentences down? Hold on. Yazan is officially making my video. I said his name. He goes, go back. Okay, so it is number 1. I have base b to the x equals b to the y. So just drop the bases and set the that's skunk equals x. Just by figuring out. What's he doing over there? He's fiercely hitting his calculator. Is that your calculator or your phone? I got bad eyes. Okay. Good. You're done? Okay. All right. So then 7x. I don't know why he's typing his calculator though. And then x equals 5/7. Looks like he's doing something other than what we're doing. That's fine. Consequences. Seniors, adults, college. Okay. Hide. All right. Then the next one. But what should you do first? And this is actually a common theme in all things when you're trying to solve. What should I do first? Should I take 20 times 2? Is that legal? That's a PEMDAS violation. Okay, so you should be arrested. What should we do next? So if I can't multiply by 20 or the 20 times 2, I divide it. Now, here's the difference on this one. I'm glad I did this. I think this is 50. 20 times 50 is 2,000. Can I, in my head, change 50 to a base of 2? Can I say 50 is 2 to this power? Yes or no? No. So this is what I mean about number 2. Number 3. If in exponential form and I can't do the first thing, just change it to a logarithm. Okay? So therefore, log base what? What goes down here? 2 of, who goes here? 50. The whole point of a logarithm is to get who by themselves? That's it. You got t isolated. Now, how do you evaluate this? You go to your calculator and do the change of base formula. Log 50 over log 2. Or ln 50 over ln 2. Or cheat and use that button that you have in your calculator if you found it. But I really think you need to know the change of base formula. All right, and then what do you end up getting? Did someone type it on their calculator? It should be 5, because you know what 2 to the 5th power is? 32. 2 to the 6th power is 64. That's between 32 and 64. So 5 point something. Just type it on your calculator. I'm done. Okay. So I don't think I have to do 2 of these, and I'm not. This one looks better. I don't even know if I'll come back to this. It's just solve. Okay, so number 1, look up here. Look up here. Write the example. Okay. And then you're left-handed, huh? All right. What do you do first? 3, 2, 1, go. You can't do anything before you get these things isolated into 3 positions. In this case, base, exponent, answer. Sorry, I had to think about that. What's 25 minus 3? It's stalled for a second. Can I take 22 and in my head make it 10 to a power? No, so I can't get equal bases. So what do? Change it. Oh my gosh, look at this. Change it to a log. What's the base of this logarithm? 10. Don't I already have a log base 10 button? Do I have to do the change of base formula? Not really. So log base 10 of who? 22 equals who? P minus 7. And what do you have to do to solve simply? Add 7. That doesn't get added to that, so it's log 22 plus 7, and then you type it on your calculator. Don't use parentheses. You're only logging 22, getting that decimal, then you're adding the whole number 7 to it. I guarantee log 22 is 10 point or 1 point something, because 10 to the first is 10, 10 to the second is 100. So you're going to get like 8 point something. Isn't that right? Okay, I'm going to move on because I shouldn't have to teach how to type on the calculator. Ooh, that's a monster. We're gonna do 2. We're gonna do both of these because that one. Oh yeah. Oh yeah. Okay. With the logarithms, maybe we'll hit a few of these here. They go fast though. Okay, so I'll slow down and do this because you don't have the notes. You're taking your own. He's just still hitting on his calculator over there. Hasn't written a dang thing down. Not one thing. He started to try to talk. Okay, now what do I do first, everybody? 3, 2, 1, go. Let's try that one more time. What do we do first, everybody? 3, 2, 1, go. Subtract 3. In this case, you need the logarithm by itself, and you need log base something of something equals a number. I have my 3 positions taken care of. Boy, there's a lot of 2's in this question. Okay, then I will tell you what people that do things wrong do. They try to divide by 2 right now. That's stuck in a logarithm. That is an illegal operation. Arrested. All right? So this is all locked in. This was not though. This was not part of the logarithm. This is free. So it's free to be subtracted, not divided to. These are the things I cannot help people with. If you divide both sides by 3, that's you came in with that bad math. I have nothing to do with that. But now I have a base, an exponent, and an answer. I got my 3 positions. So I get rid of the word log. What's the base? You can almost not get this wrong, but what's the base? 2. What's the exponent? This one you could get wrong. 2, and then what's the answer? To be or not to be? Okay. All right. 4 equals 2b. Oh my God. Then what's the answer? 2. That was ridiculous. Okay. So you get a logarithm and it's 3 positions. What are you doing over here? What are you looking at? You're looking exactly perpendicular to where you should. Wait, that's not true. You're looking in the exact opposite direction you should be. Have you already done logarithms in your life? Okay. Just don't bother the rest of the class. This is strange. I've never seen anything like this before in my life. Oh. Okay. Now I'm going to do this. Are you okay back there? That worries me in that back corner. You are almost in the next room. You are so far away from me. You could not be farther than you're in the furthest point of the room. What do you think I do first? What do you think I do first? Add 9. Okay, so you add 9. So the whole point of these, I found, it doesn't matter. The whole point of these is you have to Get the logarithm isolated. What's the next thing I should do? What's the next thing I should do? 3, 2, 1, go. Divide by -10. Not add 4, never divide by 3. This is stuck. That's like a PEMDAS violation. Those are stuck in grouping symbols with a logarithm operation. So I get goofball. As soon as you add 4 and divide by 3, you're instantly almost all points off. You are that's math you came in here with. You still do not know how to balance an equation correctly. And I do have people in here that's happening. This is why we're not passing. I don't know how we got this far if that's the case. I'm going to be honest, and that's why people don't like me. And guess what? I couldn't care less. All right? I couldn't. We got so many things that are, I got to move on. And believe me, we are trying to make it slow here. But we got to move on at some point, and it's up to you to pick yourself up. Is that legal? Yeah. You better bring it to me because then he'd feel slighted that. Yeah, right. Coffee? You spend $4 on coffee? I'm just kidding. All right, got it. Okay, you may sit down. Okay. Okay, so now what do I do? What do I do? Oh, wait, I asked to answer a question. Go ahead. Yeah, but you know what? You can divide it when you're solving. I agree with you. She just made up a great point here that you could make this an exponent. But you know what? For solving, that's going to make things worse. You'd be better off dividing it. Yeah, but you're going to get you got a negative 10th power. Boy, you're creating a world of hurt. What's going to happen next? And legally, you can do that. It just would make it a lot more challenging. And then you probably have some extraneous solutions because you have a 10th power in there, and then you got a 10th root. I don't know if you get all that because you'd have something raised to the 10th power. And then there's a negative exponent. There'd be flipping. Whew. You made that question like huge, but I love the question. That's good. All right. So what do we do next? What do I do next? Base, exponent, answer. So what do we have? Who's the base? Five. That's a 5. 5 raised to the what power? No. 5 raised to the 4 equals what? 3x minus 4. I know you miscopied or something. Those are 5s. That's a 5. That's a base 5. Okay, we got to move on. Who said they're lost? Because I'll find you. All right. All right. So base exponent again. This is how you just got to know the basis of a. So what's 5 to the 4th? 625. And then equals 3x minus 4. And then you add. Now you're free to add 4. 3x equals 629. And then x equals 9, 10, 11, 17. Does anyone know what I just figured out? If 629 is divisible by what? 3. And it is not. 9 plus 2 is 11, plus 6 is 17. If 17 isn't divisible by 3, then fumble. 629 is not divisible by 3. Okay, now I'll come back and maybe do that one, maybe. I am going to do this one because for the first time in forever, this is going to happen. Okay, so this is a good one to write. Shh. He knows everything, so he's talking. All right. Okay. That's a 4, by the way. All right. So if you notice on this side, how many logarithms do you see? 2. So from yesterday, what's the sum of 2 logs? What does that turn into? What operation? Multiplication. And this is how it happens. Log base 4 of 8 times x squared plus 1. So that was the wax on. Say it. This is why you do this, because many times when you're solving real world problems with logarithms, this could result. And now this is the time I want you to understand something. And the other teachers may be doing a mathematical operation on there, and I think it's more confusing than this. What did What did x equal in this equation? What did x equal? Skunk. Why is that applicable? Because of log of this equals log of that. The only way that's true is if this equals that. And on this equation, this is the first time this happened. This is the first time that I have log of this equals log of that. The only way that that could be true is if this equals that. And now be careful, because now I'm going to get goofballs on this last question. Just drop that log. But Mr. Samuelus, you did drop that log because it's gone in this next spot. No, I didn't. I changed a logarithm to an exponent by repositioning everything. That is a completely different thing than log equals log, drop the logs. So I want you to understand those two differences right now. As soon as you drop that log and just, I don't know, even know what would happen after that, you're gone. No, that one has to be change a logarithm to exponent. This one, log equals log, drop the logs and solve the remaining scenario. Now, you could argue what you might want to do next. I'm just going to go ahead and distribute, I guess. 8x squared plus 8 equals 10. Oh, I should have said something. Darn it. You always got to check your answers in logarithms. Actually, I should do the opposite. Wrong, Mr. Samus. That's not factorable. By the way, isn't everything divisible by 2? Right? But I'm going to go ahead and subtract 8 and then divide by 8, and then that takes care of business. X squared equals 1 over 4. And then I square root. I was going to bring the 10 over here, but I don't have a middle term. So what you want to do is solve, just like we did in chapter P, by getting x squared by itself and square rooting. By the way, and this makes me cry, but what's the square root of 1? What's the square root of 2? 4, shucks, 2. And then what should I put in front of this? Plus or minus. I forgot something. Whenever you have a logarithm equation, you better check your answers. Here's what cannot happen. You cannot have log of 0 and you cannot have log of a negative number. Sometimes when you solve, you get answers that one of those two things might happen. So the only thing you have to check is, does that happen? Well, this doesn't have an x here. 1/2 squared plus 1, is that still going to be a positive? Yes or no? Yes? Oh my gosh, that was more of a catapult. Can you, there was a kind of a fumble, but she almost hit you in the back of the head with that thing. And then what's negative half squared? Is anyone listening? Okay, I got to move over here. Okay, is anybody listening? I see people staring off into the distance over here. So what's negative half squared? Is that positive? Yes or no? Plus 1, is that positive? Yes or no? Both of these answers work. Where else did I have a logarithm? I had this one. Okay, the only thing I have to worry about is 629 thirds. When I plug that in, multiply by 3 and minus 4, is that going to be a positive? Yes or no? We're done. We're good. We don't have to really check any further. Was this a logarithm? 2. 2 times 2 is 4. This is easy to check. 2 times 2 is 4. What's log base 2 of 4? Everyone should know that answer. 3, 2, 1, go. 2. What's 2 plus 3? So that checked. But anyway, I just wanted to make sure I didn't have a negative in there. Okay, now. Oh, you want to get nuts? Let's get nuts. Put a big star by this one. Big star. And then we have 2 more challenging ones I'm going to do. Then if you want to pay attention to a couple more I do, that's fine. This one this is the biggest one. This is the separator from the A students. Like the A students will understand what I'm doing here. And then again, there is another way to do this. Whatever I do to one side, say it. Do to the other. You could, if you learned this last year, I guarantee all of the Math 3 teachers did this. They logged both sides, and then they pulled the exponent out in front. I think, a way that's slightly easier. You can treat this as an exponential, but pick which one is the base. I picked the base that has the more complicated exponent, and I'll tell you why. Base, exponent, answer. One reason I do this is you can do every question the same way then. When Mr. Samuel says I have an exponential, I need to change it to a logarithm. If you want to do what you did last year, go for it. But I'll tell you why this way is easier. All right, you ready? I'm going to change this to a logarithm. Because of my choice, what do I make this? 3, 2, 1, go. 7. So that's got to be 7. That was my choice. What goes here then? 3, 2, 1, go. 4 raised to the x. Careful on that. And now equals what goes over here. And then all I know I have to do is I got this nice. I don't have a logarithm over there. That's why this is easier. Okay, Sahara Desert. All right, and then okay, what do I do about this now? What do I do about this x, which is what you did last year, and then what I showed you is one of the rules. What do we do with it? Put it out in front. Now this is what makes me sad. How many students can't go from here? Really, what you've done. This is just a decimal. That's just a decimal. This is actually now an 8th grade equation. But you got to make it an 8th grade equation by calculating that. So how do I calculate log base 7 of 4? Fine, I'll open up the calculator. It'll take a half hour for it to open. Oh, nice little break. Now I should show you calculator ready form, but I just feel like there's some things I just want to make sure everyone's successful here. And calculator ready form isn't used as much anymore. If you go to college, I bet your professors show you what calculator ready form is, and if you get to that point in a higher level math class, you'll be able to handle it. It's not that bad. So I got to type log 4. If you're lazy, press enter, and then divide that by log 7. I want to make sure I'm hitting that. If I don't feel like closing that parenthesis, and I get 0.7124. Hold that there, though. So that's there. My fat head's in the way. I got to move this over. Okay, so what was that? 0.71 what? 0.7124 dot x equals 3x plus 2. That is a grade school equation. I'm sorry. I know you solved decimal equations in grade school. What do I do next to balance this equation? Subtract 3x from both sides to get the x's on the same side. Well, how do I do that? Go to your calculator and hit subtract 3 from that decimal, and now I get negative 2.28x equals 2. And then what do I do next? What do I do next to solve for x? Divide by what? So it's 2 divided by negative 2.28. This is how you handle this on your calculator. 2 divided by second answer. And guess what? I never rounded. Because I kept going into my calculator with the decimals all the way out. 0.87 negative, 0.8742, then I'll round to the 10th maybe. X equals negative 0.87. Boom. So all I had to do was do a logarithm once to get a decimal equation from grade school and know how to balance it. And I used my calculator to never round until the end. Okay, so it's a little bit easier because there's less logarithms to do, less decimals that happen. You can do your thing you did last year as well, and you get a right answer as long as you're okay with your math. And now you want to get nuts? Boy, we've got nuts a lot today. Let's get nuts. Okay, I had a thought. I had an epiphany. That means a mind thing popped in my head. And after this, you can go ahead and start your homework if you wanted. Actually, you could do it now, but I think you should watch this. This one gets a little hairy. But do you like fractions? Yes or no? 3, 2, 1, go. No. So what can you do to both sides to get rid of that a half? What can you do? Multiply by 2. I did not do this ever. I've done this example for probably 10 years straight. And I'm like, I just thought to myself, why the heck did I not just get rid of the fraction? It would make it a lot easier. Distribute, you get 2 log x. And then 2 times a half is 1. Oh, sorry, that's a minus. That's a brain fart. Minus log of x plus 4. And then that equals now 2 instead of 1. And then that's a lot easier. And no, Tina, right? We don't want to make that squared because we're doing the opposite. We want to get this, wait, I do. I'm a liar. You're right. You want to make this an exponent here. So I'm just going to do that right now. I have to do that because now what's my subtraction rule? What's this going to turn into? What operation? Division. So sorry, it was a reversal of not. You definitely want to use the exponent rule, so then you could use the subtraction rule. And it's x squared over x plus 4. This is why you need me and you should pay attention because a lot of things happen from here that students are not ready for. The next step is pre-calculus. The rest of it is freshman year. All right, I'm just being honest. The pre-calculus part of it is what do I do next? First of all, how many logarithms do I have? How many logarithms? No. How many logarithms do you see over here? 1. Do I drop the logs? No. What's the base on this logarithm? 10. So first of all, you might want to remind yourself of that. Since I have 1 logarithm, I change it to an exponent. So what's the base? What's the base? 10. What's the exponent? 2. What goes over here? See, and I just think people don't see that this is changing an exponent to a logarithm. Wrong. Changing a logarithm to an exponent when I jump from one step to the next. This is the base. It may be highlighting. Base. This is the exponent. This is the answer, which that's goes on the other side all by itself. Once you get that accomplished, the rest of this is freshman year. But boy, how many people cannot solve this from here? Maybe sophomore. 10 squared is a hundo. And then how can you solve this x squared over x plus 4? What can you do? This is over 1, by the way. So what am I trying to get you to do? Cross multiply. Okay, and then we're in CAD. I should be able to do this. 1x squared equals, actually, I'm going to do 2 steps in 1 on this next one. 100 times x plus 4. And then I'm going to distribute and subtract. This is 100x, but then I got to bring it over to this x squared. You know what? Maybe not to confuse you, I will keep the x squared on the right side of the equal sign. I'm trying to accomplish 0 over here. 100x, and then to subtract it across means it's 100 minus 100x. Positive 400, but then I got to bring it over here, negative 400. We should be able to do this at this point. This is basic equation solving and balancing. And then, oh no, does anything multiply to be negative 400 and then the same 2 numbers add to be negative 100? Do you think there is? Fumble. Let's just try the what then. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Are you okay, Jake? You look ticked off at this problem. All right, this is cat. I'm going to go a little farther than a meow because this is a big one. This is a big one. All right, so now 100 plus or minus square root of, I got it. Negative times a negative, I'm going to change colors. Students are really bad at this sometimes. This is going to be a plus. Still listening back there? Okay. And then 4 times 400 is 1,600. 1,600 plus 10,000 is 11,600. Don't fret. Go to the calculator. 100 plus 600. I don't care about simplifying this radical when the numbers are this big. And then don't forget about, I hit enter on the numerator, then divide by 2. Do not forget about dividing by 2. Okay, then I'll show you how we check our answer. Are you nuts, Mr. Samuels? So that was 103.85. And then the other one, you know what? I just don't feel like typing those real, and you can do this. Press enter and then change that to a minus sign if you don't feel like, and you could do a lot faster than I just did it. Now get the minus answer divided by 2. Divided by 2. Sorry for showing the calculator so small, but you shouldn't have to be taught how to type on the calculator. Negative 3.85. But wait, there's more. Remember what I said about a logarithm? You cannot log a negative or 0. When I plug in 103, am I okay for x? Yes. When I plug in negative 3.85, am I okay? Yes or no? No. This answer is extraneous. This does not work when you're solving a logarithm. And I guess that took us to the bell anyway, so I've done enough. Okay, so that's when you have to use and that's going to happen to you in your homework. You're going to get a quadratic formula example. All right, I'm done. Whoo, that was a mouthful. Mister, what?